Hello, my dear students. This is Physics Balaji. Today, let us discuss a problem based on kinematics. It is given in recent JEE Mains question paper. A cannon fires successively two shells with each speed 10 meter per second. The first at an angle 60 and the second at an angle 45 degrees to the horizontal in the same plane. Here, a cannon fired two shells. First one, second one, with same speed 10 meter per second, but with different angles. One is at 60, other is at 45 in different time intervals. Successively he told of different time intervals. Maybe it is the first one, time taken to reach this point is t1, and after some small time interval, second one projected, it reaches the same point in time t2. Now at this point, they collide with each other. So at this collision point, for both of them, vertical height is some y and the horizontal distance is some x. Now we are asked to find horizontal distance where firing leads to collision of the shells. So they meet at this point. For that horizontal distance they are asking x value. For first body, along x-axis, let us apply s equal to ut plus half at square. Along x-axis. So displacement along x-axis for first body is x. Initial velocity along x-axis will be u cos 60. Time interval first body t1. Along x-axis there will be no acceleration, a0. So the next becomes, we know u value was 10. 10 cos 60 value 1 by 2 time t1. So we will get x value as 5t1. Apply the same formula for along y-axis also. So y equal to, along y-axis initial velocity will be u sin 60 into time t1, upward direction y-axis minus half gt square. Along y-axis this will be u sin 60, so gravity will be downwards, so this will become minus half gt square. Now what happens was, y will be equal to u value 10 sin 60 value root 3 by 2 into time t1 minus half g value 10 t1 square. So if you simplify, you will get like this, y equal to 5 root 3 t1 minus 5 t1 square. Now same thing we will apply for second body also. For second body, initial velocity 10, but angle is 45 now. Now what happens? For second body, so x becomes 10, in place of 60, keep 45. Cos 45, time was t2 now for second body. So then you will get x value as 10, cos 45 1 by root 2 into time t2. So x becomes 5 root 2 t2. Similarly, along y-axis also. Along y-axis also same thing. Y equal to u10. Here it is 45 degrees, sin 45 1 by root 2 time t2 minus half g t2 square. Simplify this one, will get y value as 5 root 2 t2 minus 5 t2 square. Here you can observe clearly, for first body and second body, x displacement will be same at the time of collision and y displacement will be same. Now you can equate x values of first and 2 and y values of 1 and 2. For first body, x value was 5t1 equal to, if we equate x values, 5 root 2 t2. Now 5 will get cancelled. t1 equal to root 2 t2 we got. Equation 1. Similarly, equate y components also. First body y component value is 5 root 3 t1 minus 5 t1 square. For second one, second body y value, 5 root 2 t2 minus 5 t2 square. In place of t1, substitute root 2 t2. Root 3 into t1 value, root 2 t2. t1 value, root 2 t2 square, 2 t2 square, root 2 t2 minus t2 square. Bring all terms to the right side. Then what happens was t2 square plus root 2 minus root 6 into t2 equal to 0. I can make t2 common. I can write this as root 6 minus root 2 equal to 0. Either t2 0 or t2 equal to root 6 minus root 2. So this can be written as, if you make root 2 common, root 3 minus 1. In the question, root 3 value was given as 1.7. So 1.7 minus 1 equal to root 2 into 0.7. t2 0 means this is nothing but equal to initial value. So at the time of root 2 into 0.7, so both bodies collide with each other. Now you are asked to find at what horizontal distance they will collide with each other. This x value they are asking. So we know t2 value, substitute in this equation, you can find x value. So now your final answer will be x equal to 5 root 2 into t2. 5 root 2 into t2 value, root 2 into 0.7. 7 meters. Thank you.